Let's analyze question number 60. For five children with ages A, B, C, D, E given, and we know that A is less than B, less than C, less than D, less than E. And it's also given that any two successive ages differ by 2 years. And the question is asking you to calculate what is the age of the youngest child. And there are two statements given. So this is an example of a value-based data sufficiency question, because the question is asking you to find an exact value of the youngest child age. So let's analyze the question here. So since it's given that any two successive ages differ by 2 years, I'm assuming that the youngest child be A, then the next child will be, the age of the next child will be A plus 2, then it's A plus 4, because it's clearly given any two successive ages they differ by 2 years, right? So the next is gonna be, again I'm adding 2 years to it, so A plus 4 plus 2, it's gonna be A plus 6, and the eldest one would be A plus 6 plus 2, A plus 8. So this would be the corresponding ages of these five children. And the question is asking you to find the age of the youngest child. So the question is asking you to find what's a value of A. So if you're able to find an exact value or a single value for A, that means the statement would be sufficient to answer the question. Now let's analyze each statement one by one. So I'm going to start with statement 1. Okay. So statement 1 says that the age of the eldest is 3 times the youngest. That's the statement 1. Correct? What's the age of the eldest? The eldest child age is A plus 8. So it's given that A plus 8 is equal to 3 times the age of the youngest. So youngest child age is A. So it's going to be 3 times A. So from this equation given, can you find the age of A? Yes, definitely you can find it, right? You can solve it and you can actually find the value of A. But since this is a data sufficiency question, you don't need to calculate the value of A. You just need to know whether it is possible to calculate the value of A. Yes, definitely it's possible. You don't need to spend time to solve the equation. You just need to know, is it possible to solve it or not. So clearly I can say statement 1 is actually sufficient to answer the question. Now what I'm going to do is I'm going to try statement 2 here. So statement 2 says that the average age of the children is 8 years. How do you calculate the average age? You have 5 children there, and the average age, how do you calculate? The sum of their age divided by the number of people. Here there are 5 children, so sum of their age divided by 5. This is how you calculate the average age. Correct? And the sum is nothing but you are adding all these values, right? So it's going to be A plus 2 plus A plus 4 plus the next child age is A plus 6 plus the eldest one is A plus 8. So this will give you the sum divided by 5 is equal to the average age, which is 8. Again, do I need to solve it or just need to check whether it's possible to solve and find the value of A? Yes, it is possible, right? Because you can cross multiply here. So the sum is equal to 8 times 5, which is 40, and you can actually find the value of A. It's possible because it's just only one variable is there, and you'll be able to find the value of A. So statement 2 is also sufficient to answer the question. Make sure that, keep in mind, you don't need to spend time in solving the question. That is not required here. That's the advantage of data sufficiency question. You don't need to find a value. You just need to be sure that it's possible to find a value. So in this question, each statement alone is actually sufficient to answer the question. So which option will you mark as the answer for this one? We'll mark option B as the right answer, because it's saying the question can be answered by using either statement alone.